In this lesson, we'll look at the intersection of two linear equations. So let's just track back a little bit to Venn diagrams. So what does it mean by intersection of two sets of data? So you can see in the blue circle, we have the people that play hockey. So Gina, George, Brooke, Victoria, Keaton, and Ryan all play hockey. So they are in this blue circle. And then we have a red circle, which are the people that play baseball. So in this red circle, we have Aiden, Victoria, Keaton, Nora, and James. But then we have an overlap of these two circles, and that's this section here is the people that play both sports. So Victoria and Keaton play both hockey and baseball. So this is an intersection of the two data sets where we're looking for that overlapping data. And we can do that graphically. When we're asked to solve an equation, we're asking to find the value of the variables that make the statement true. So that's what solve means. And if we were checking that statement, we would use a left side and right side check to make sure that our solution is correct. So when we solve, we are getting a solution. We can solve a linear system of equations. So a linear system is two or more lines. Two or more lines. So in grade 9, we just do 2 lines. As you get into higher grades, more senior grades, you might do 3 lines or 4 lines. But for the purposes of grade 9, we're just going to do 2 lines. So we want to solve a linear system meaning 2 lines, and we want to find that intersection point or that point that satisfies all the equations. So we are comparing solve to finding the solution, which is also the intersection point of the system, and we will say that the point satisfies the system. So those all mean the same thing. So we can do this graphically. We might have a picture of 2 lines. So here we have line 1, which is 2x plus 4. That would be the blue line. How do I know it's the blue line? Well, it has an initial value of 4, and so does 2x plus 4 has an initial value of 4. And then the red line is x plus 1, which has an initial value of 1. So I can determine which line is which. So this is line 2, and this is line 1. So remember, I'm comparing that to my equation y equals mx plus b, which is a linear equation, and I'm looking at the initial value to determine which line is which. Okay, so the intersection point is right here where they cross. So this is where they meet. So I would say the solution is the point -3, -2. Right? I go left 3 and I go down 2 to find this point. That is the intersection point. How do I know if I'm right? Well, I can check the point in both equations to see if it satisfies both equations. So I'm going to check it in the first equation, which is y equals 2x plus 4. Remember, when we check, we don't put an equal sign, because we are checking, so we are trying to find out if they are equal. So this is sort of your first introduction to proofs. And then the second equation was y equals x plus 1. So we're going to put in the values for x and y into our left side and right side and see if the left side equals the right side. So y equals -2 and x equals -3. So that would be -6 plus 4, which is -2. So it checks in the first line, line 1, y equals 2x plus 4, and then I'm going to try it in line 2. So y is -2, x is -3, -3 plus 1 is -2. It checks in that. So in order for it to be the solution, it must satisfy both equations, meaning that a left side, right side check would be valid for both equations. We might also use a table of values. Maybe we don't have a graph, so we want to find a graph by making a table of values and plotting the points. So the first line we're doing is 2x minus 9. And then the second line we're doing is y equals 6 minus x. If you want to put it in mx plus b form, you could put the rate of change first, which is negative x or negative 1x, and then 6 is the initial value. So when I'm graphing, we usually pick a couple of negative values, a couple of positive values. Actually, I'm doing this one in blue, so let's change colors here. So we're going to use a couple of negative values and a couple of positive values. Remember, with your values, you can use whatever value for x that you want, unless there are some restrictions on the situation. But for the most part, we like to use a couple of negative, 0, and a couple of positive. That's so that we can see both sides of the y-axis and both sides of the graph. Okay, so the first equation is 2 times x minus 9. So 2 times negative 2 is negative 4, minus 9 is negative 13. 2 times negative 1 is negative 2 minus 9. 2 times 0 minus 9. 2 times 1 minus 9. And 2 times 2 minus 9. And just to verify, I can see that I'm increasing my y values by 2, which is my rate of change. And I can see that my initial value is 0, negative 9, which is indicated here in my equation. So those points look correct. So I'm going to plot those points. So we started with the table. This time we're graphing 6 minus x or minus x plus 6. Again, I'm going to use a couple of negative and a couple of positive. So it's going to be negative 1 times 2 is negative 2, or positive 2, plus 6 is 8. And then we have negative 1 times negative 1 is 1, plus 6 is 7, 6, 5, 4. So again, I can check my rate of change. My x values are decreasing by 1, which is indicated here in my rate, and my initial value is 6, which is indicated here. So I can plot these points on the same grid, and then we had negative 1, 7 in this grid. We'll do it in blue. Negative 2, negative 13, which is here. And then we had negative 1, negative 11, 0, negative 9, 1, 7, and 2, 5. So here is my blue line. I could follow the rate of change and keep going if I wanted to find more points. So I can see that I'm going, every time I increase x by 1, I go up by 2. So if I go 1, up 2, 1, up 2, and I could just keep doing this forever to find more points on the line. Oops, it's the wrong spot. All right, so you can follow your rate of change to make more points in both directions. So that looks like that's got enough points. And so this equation was y equals 2x minus 9. Okay, let's go back to, let's do it in red. So we've got negative 2 and 8 is up here. And then we had 0, 6, and 1, 5, and so on. So again, I could keep following this rate of change by going down 1, right 1. And I want to keep doing this until I intersect this blue line. So once you have the rate of change, you can keep going until the two lines intersect. So it looks like the points line up at, let's see, it's hard to read on the graph. And that's one thing with graphs. Sometimes it's hard to read. Oops. We'll write it down here at the intersection point. So it looks like it's at 6, 2, let's see, 3x. I think it's at, okay, let's follow this rate of change here, and the one, I think we got it at the wrong spot. It looks like it's at 5, 1. So when x is 5, y is 1. Okay, and we can see if we're right. Sometimes it's hard on a graph to see where it is, so we're going to check with our left side, right side equations to see if we're correct. So left side, right side, the red line is y equals negative x plus 6. We have a value for x of 5 and y of 1. So y is 1, x is 5. So negative 5 plus 6 is 1. So it checks in the red line, and let's check it in the blue line to see if it is correct. That equation was y equals 2x minus 9. So again, y is 1, x is 2. 2 times 5 is 10, minus 9 is 1, so it checks in that line. So we were correct. 5, 1 is the intersection point. So that's one way to find graph by making a table of values. You could also use the initial value and rate of change to graph. We don't have to make a table of values. So if I have 2x minus 9, the initial value is negative 9. So that means 0, negative 9 is on the y-axis. So I could plot that here. And then my rate of change, or the difference in the y over the difference is the x, is 2, which would be over 1. So from this point, it means every time I increase 1 on the x, I go up 2 on the y. So from here, I'm going to go right 1, up 2, right 1, up 2. And I could just keep doing this, following this rate in either direction. So I could also go down and left. Down and left. So up, right, down, left are the opposite directions. Draw that very well. And then the second one, the initial value is 6, or actually, yes, 6. We need to rearrange this one. We want the y by itself, so we'll move the x to the other side. So the initial value is 6. So 0, 6 is on that line, and then the rate, or delta y over delta x, is negative 1, right? There's a negative 1 here. So that's over 1. So that means from this point, every time we increase x by 1, we go down 1. And then we would just keep doing this until we crossed the other line. And so we can graph that way. We don't have to make a table of values. You could also use the initial value and the rate. A little bit trickier. Table of values is a good way to do it if you're not quite sure how to do rate of value and initial value. But remember that you only need 2 points to make a line. Once you have 2 points, you can connect them to make a line. So the initial value is 1 point, and then you can follow the rate to find a second point. So either method works. You can either use a table of values, or you can plot using the initial value and the rate of change.